As per discussion with the valence shell electron repulsion theory, now we will draw the shapes of some molecules for which we should note some important points. Number one, that repulsion between lone pair is highest in comparison to the lone pair bond pair, and which is more than the bond pair repulsion. Second is repulsion due to triple bond is more than the double bond, and it is more than the single bond. Third point is lone pair occupy more space in space because lone pair is attached to the single central atom while the bond pair is shared between the two atom or nucleus. Also, the presence of the lone pair on the central atom causes the slight distortion of bond angle from the ideal shape. Because bond pair and lone pair of the electron take some space, therefore all electron pairs repel each other so that the electron pair orient themselves in the space as far as possible to have the minimum repulsion and more stable configuration. Let's write some general shapes. Number one is if number of electron pairs in valence orbital are number 1, say 2, then the shape of molecule will be, it is linear, and bond angle will be 180 degree. Similarly, if it has 3 electron pairs, then shape will be plane triangle. That means it is a triangle in a plane, and it will have 120 degree bond angle. Figure will be like this. Say this is the central atom and 3 bond pairs or lone pairs are at the vertices, and this is in a plane, and angle between these bonds with the center will be 120 degree if these are purely the bond pairs. If there is a lone pair, then there will be some distortion. Third, if number of the electron pair are 4, then the shape will be tetrahedral, and in ideal case bond angle will be 109 degree 28 minute. And tetrahedral is actually the 4 vertices in this shape, and it is connected in this way. Fourth is if number of the electron pairs are 5, it is trigonal bipyramidal. Pyramidal or pyramid has the triangle base, and it is having the 2 bond pair up and down, and so we say it is a triangular bipyramidal. Bipyramidal means it has a triangle base, and 2 bond pairs will be, one is up inside and one is downside. Therefore, it will have the angles 120 degree with the central atom at the plane, triangular plane, and 90 degree which are at the apex, one up and one down. Sixth is if the electron pairs are 6, then the shape will be octahedral. In octahedral, the base will be square, and one bond pair will be up and one bond pair will be down, and this will has the angle 90 degree in plane as well as in apex positions. And one more is, say if electron pairs are 7, then it is pentagonal bipyramidal. Pentagonal bipyramidal means the base is pentagon, 5 sides shapes, and one bond pair is in apex position and one is in down, and this will have the angle 72 degree in the plane. This means if this is central atom, this angle is 72 degree, and the other angle is 90 degree with the apex positions. So in this way, they are the in general 7 shapes we have discussed. Now we take some molecules and draw their shapes. Let's take first is BeCl2, barium chloride. it has number of the bond pairs plus number of lone pairs. Number of bond pairs in the BeCl2 is 2 and lone pair are 0, hence its shape is linear and bond angle is 180 degree. One more is BF3. It has 3 bond pair and 0 lone pair and it has plane triangle shape and angle will be 120 degree. BCl2 is like this, it is linear and this bond angle is 180 degree. Similarly, if we see BF3, this is B, this is F, this is F, this is F, and if we complete this, it is a triangle and this angle, we say it is a bond angle, it is 120 degree. Third is NS3, or we say ideal case, that is Ch4 methane. In this Ch4 methane, there are the 4 bond pair and 0 lone pair. It has the shape of regular tetrahedron. That means it is ideal case. And it has the angle 109 degree 28 minute. And shape will be C, H, 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 H. And this angle is 109 degree 28 minute. So these 3 cases we have discussed are the ideal cases where there is no distortion. Now we take one more example, say NH3. Here there are 3 bond pairs and 1 lone pair. And this lone pair exists on the central atom, that is the nitrogen. Therefore, its shape is pyramidal. And shape will be just like that. It is 1 H, H and H, and lone pair is in this way. So this lone pair and here these bond pairs between N and H will have a repulsion, and this repulsion results into the decrease in the bond angle, and this bond angle for the NH3 is 107.48. Similarly, if we check for H2O, here there are the 2 bond pair and 2 lone pair. These 2 lone pairs are on the oxygen and the shape is bent. And angle between the bonds is 104.27. If we see the shape of the H2O, this is the O, it has 2 electron pairs and these are the bonds. And this angle is 104.27. And if we draw the lone pairs also, then the shape of the lone pair will be like this. And this lone pair repulsion causes the more distortion in comparison to the ammonia. Therefore, its bond angle is lesser than the NH3. Next example is F2O. Here F2O has 2 bond pair and 2 lone pair. Therefore, its bond angle is 102 degree. It also has the bent structure. And here more distortion take place because here oxygen has 2 lone pair as well as this fluorine is most electronegative element. So it also affects the repulsion. Similarly, if we take NF3, it has 3 bond pair and 1 lone pair, and this nitrogen, in comparison to nitrogen, this fluorine is the more electronegative element. Therefore, here the bond angle for NF3 will be 102.30. Similarly, if we take PCl5, here it will have 5 bond pair and 0 lone pair, and it will have the shape trigonal by pyramid, and bond angle will be 120 degree and 90 degree. This is the regular shape. And distortion occurs when there is a lone pair. For example, SF4, this contains 4 bond pair and 1 lone pair, and here angle is this shape is deformed and angle are 101.8 36 and 86.33. Similarly, if we take ClF3, it has 3 bond pair and 2 lone pair, and here angle is 87.40. Also, this I3 minus, it will have 2 bond pair and 3 lone pairs, and these 3 lone pairs will be on the triangular plane, or we can say equatorial plane, and the 2 bond pairs will be in the apex position. Therefore, its shape will be just like linear shape, and bond angle will be 180 degree. If we draw the figure of I3, then this is the I, and it has 2 lone pairs here, 1 lone pair, another lone pair like this, and 1 lone pair is here, and 1 lone pair is this. This will form a equatorial triangle, and the 2 ions, I ions or I atoms, will be in the equatorial position. So angle between these will be 180 degree. Similarly, we can draw more figures like SF6. It will have 6 bond pair, 0 lone pair, and shape will be regular octahedron. It has a regular shape, and there is no deformation, and bond angle will be 90 degree. We can draw this SF6 as this is S, and there are the 4 F at the corners, and 2 F's are in the apex position up and down. Other similar shape is BRF5. It will have 5 bond pair, and 1 lone pair will have the octahedral shape, which is deformed because of the lone pair, and the angle will be 84 degree 30 minutes. Ch4 will have the 4 bond pair and 2 lone pair, and it will also have the shape octahedral, or we can say it is a regular square planar, because here in Ch4, Xc has a square with fluorine at the corners in the equatorial plane, and 2 lone pairs will be in apex up and down positions. This is Xc. Also, one more is IF7. It has 7 bond pairs, 0 lone pairs, and it has a regular pentagonal bipyramidal shape. And we can draw this as this is a pentagonal, and in center this is I, and 5 F are at the corners of a pentagon, and 2 fluorines are at apex position in the up and down. One important note is that lone pair always occupies equatorial position in a triangle. That means if shape is triangle, then it will occupy the equatorial position, then the apical position, that is up or down. For example, here in this case, this is I3 minus. In this case, they are the 3 lone pairs. So these 3 lone pairs will be on the equatorial positions, and I are in the apical position. So lone pair always take the equatorial position in a triangle. This point to be remembered.